Thank you for watching this video. I'm Shivani and welcome to my channel CD. Today in this video we are going to learn about a special type of distillation known as steam distillation and why is it called so. If you remember in my earlier uploads there is simple and fractional distillation. The main criteria about it was the liquid should not decompose during distillation. But if we have some compounds to distill which decompose at their boiling points, then what to do? So if you want to know about it, stay tuned. So steam distillation is a special type of distillation which is required to distill or separate liquids that decompose at its boiling point. And simple distillation is mainly aimed to distill the liquids below their respective boiling points without decomposition of their respective compounds. Steam distillation is mainly used for separation of temperature-sensitive compounds like natural aromatic compounds and, for example, isolation of essential oils, which is required in perfumes. Let's move to the schematic representation of steam distillation. This is the schematic representation of steam distillation. First, suppose a system contains three different organic liquids A, B and C, and the most important fact is that these liquids decompose at their boiling points. So the first step is to allow steam to enter the system, and at the same time heat is provided to the system also. In the second step we observe the boiling condition of the system, and an important factor is when the sum of vapor pressure of two immiscible liquid is greater than 1 atmosphere, solution boils below the boiling point of each individual constituent. That is, when a mixture of two immiscible liquids is heated, each constituent independently exerts its own vapor pressure as a function of temperature as if the other constituent were not present. Consequently, the vapor pressure of the whole system increases. Boiling begins when the sum of the vapor pressures of two immiscible liquids just exceeds the atmospheric pressure. As we know that at 100 degrees Celsius the vapor pressure of water is equal to 1 atmosphere. So, as water is one of the components of the system, so sum of vapor pressure of one of the other components of the system and water would be greater than 1 atmosphere below 100 degrees Celsius. In this way, many organic compounds insoluble in water can be purified at a temperature well below the point at which decomposition occurs. For example, boiling point of B is equal to 157 degrees Celsius and that of water is 100 degrees Celsius. So, from the fact we learned now, a mixture of the two will boil at 97 degrees Celsius, which is well below the boiling point of each component B and water. So B can be easily distilled at 65 degrees Celsius below its boiling point. So the next step will be to condense the vapors of B and water, and by which we can get the liquids of B and water as a mixture. Now as B is organic and water is inorganic, so we can get two layers of B and water differently from which B can be extracted. Now let's move to the diagrammatic representation of steam distillation. This is the diagrammatic representation of experimental setup of steam distillation. This represents the round bottom flask, that is RB, in the experimental setup. This is the condenser with one water inlet and one outlet to maintain low temperature inside it. This is the safety valve. And the first round bottom flask contains water, which is a difference between the earlier types of distillation, that is simple and fractional distillation, which contained only one RB containing the compounds to be distilled. But in case of steam distillation, the first RB contains water, not the compounds to be distilled, and the second RB contains the compound to be distilled, that is A, B and C. So the first step will be to apply heat to the first RB containing water. so that the water vapor will move through the mouth of the first RB towards the second RB. As a result, the second RB will contain compounds to be distilled and water, that is A, B, C and water. And the next step will be to apply heat to the second RB also, and due to which the vapors of B and water will flow towards the condenser, and the RB will contain only A, C and the water. Now the important fact is that as the vapor pressure of B and water was greater than the atmospheric pressure, so a mixture of vapor B and vapor of water went inside the condenser, and it will be followed by condensing of the mixture of B and water to get a mixture of liquid B and water as two layers. So the first layer will be of water, while the second will be of the distilled liquid, that is B. So in this way we got the pure liquids of B without its decomposition. In the similar way, we can also distill A and C by increasing the temperature according to their boiling points in the second RB. And so steam distillation is a very special type of distillation to get the separation of liquids without its decomposition. So thank you very much for watching this video. Like, share and subscribe, and press the bell icon for notifications, and thank you very much once again.